Then we will, in an implementation, in the best practice or example of an implementation of SNOMED, you would have a terminology server. So that's where you hold all the information related to the terminology. Nothing related to patient data, only the terminology, the descriptions, the concepts, the relationships. That semantic network, that is what is held in the terminology server. And then the two communicate, right? So when you look up a diagnosis, you would go via the user interface, and then you would query into the terminology server that will show you some terms. I'll show you that later on. But that's how you would set up a clinical record that uses a terminology server. And you would use often you would use a service-oriented approach where you access the terminology via an API. So that's to separate what a health record and a terminology server is. This afternoon, I'm going to talk more about this, but just keep in mind that you seldom, it is a possibility to actually hard code SNOMED codes into your system. Of course it is. There are codes and there are terms, you could do that, but it's not very efficient because, as Ian also said, we have frequent new releases, and that would require a lot of maintenance to do it that way. So having this more service-oriented approach is really a recommendation because it allows the services to be reused in multiple systems, and it will be easier to update and maintain over time. Just close this. And in the clinical record, SNOMED CT can support a range of tasks, such as searching for the specific content you want, entering it into the system. It can also support data retrieval and analytics, knowledge linkage and decision support, and communication exchange. So that's like the span of tasks that you would want to use SNOMED CT for. So let's dive into search and data entry with SNOMED. Some of this will be repetition, but that will reinforce the understanding. So one of the requirements for clinicians on the floor entering data into a system is that the language and the terms are recognizable. As we just spoke about in the break with the gentleman in the back there. So when you implement a terminology, it's very much about bringing awareness about what it can do. Because if you show someone in Paris what they do in Bordeaux, even within the same field, clinical domain, they may say, well, that's not entirely what we do. We want to look at things like this, and it should be these terms. But that doesn't mean that they can't use the same standard at the back end, right? So it's okay to acknowledge that within specific departments, domains, there are variations. That's the premise. And that's what you need when we implement SNOMED and when we implement standards. We need to be aware and acknowledge that is a premise and work together with the end users to actually obtain something that can work both in Bordeaux and in Paris. And one of the things is that to discuss what language do we use? Where is it okay to vary? What do you say? What do we say? And fortunately, SNOMED is designed in a way that you can allow both. Then it's of course important that when you show terms or things that you can enter in a record for a clinician, that the clinician is not bombarded with things that are irrelevant. So if I want to document some disorder, I don't want to see pharmaceutical or drug products, or I don't want to see anatomical structures. I should only see the things that are meaningful to me in this context. And I shouldn't be able to, and I shouldn't see codes and symbols. So we shouldn't require them to remember that J something means something specific. And this is about the relevant options. And the end user preferences should be applied. And that relates to the example I gave before. Yeah, we should really acknowledge how they work and try to make the standards work with, adapt to that. This is about the language and the terms that you can, in SNOMED, you can add terms in any language or dialect, which means that in one system you can use the term heart disease, while in other systems you can use cardiopathy. And you can even use the same search feature. And irrespective of what term you use here, it would be the same concept that you store, namely this one. We even see systems where we allow natural language processing, so that you can just enter something and then there will be NLM or natural language processing algorithms that can suggest what are the codes that you want. So there are different ways to do that. And a key principle for when you store or when you display terms or concepts in SNOMED CT is that you don't display the identifiers. In the tool that I'll show you in a minute, you'll see that you don't see any identifiers. So they are designed for the computers and not for the humans. And then it's, of course, any implementation will require you to agree on what are the terms that we will use. Yeah, and this is just to exemplify that the codes doesn't make sense, but as soon as we display the terms, we can actually understand what's going on. So remember, when you work with SNOMED CT, that the codes are for the databases and the terms are for the user interfaces. We use the codes for querying, for exchange and storage. Only relevant options should be available. And that's, of course, to reduce the amount of time it takes to search and identify what is relevant. This afternoon, I'm going to show you the SNOMED browser. And maybe have some of you seen the SNOMED browser? It shows everything. It's increasingly complex because SNOMED has many features and it allows you to do a lot. So try to give that to a clinician and ask them to find the thing they want to record. No, that's a no-go, right? So you need to make sure that when you implement SNOMED CT in a system, don't give them the browser. Give them something that makes it easy to select what they are or find what they are searching for. Because time is limited in the clinical field, we know. And one of the key principles of implementing SNOMED is that you constrain your data elements to specific parts of SNOMED. So that when you want to record a diagnosis or symptoms, you only use concepts that belong to the clinical finding hierarchy. Or when you capture the results of an observation, again, you can use the clinical finding, but exclude anything else, because it's in the clinical findings that actually represent this type of meaning. So when you record procedures and tests, care and therapy, nursing procedures, use the procedure concepts and exclude everything else. What was it you said, Ian? We had more than 500 concepts, 350 active concepts. So we should really make sure that the clinicians are not faced with 350,000 options every time. And again, it's just arguing. So we have a broad terminology that has benefits, but in a real life and end user situation, it's about hiding that complexity. And then about how you want to record information. You may speak with some clinicians in one department that likes drop-down lists or like checkboxes or just like free text fields. And SNOMED CT or SNOMED International we don't dictate, well, if you're recording this type of information, you need radio buttons or you need checkboxes. We don't control. We don't have any say or any opinion in what you should do. We have some recommendations and guidelines that are more general, but then it's up to implementers and you to figure out what works well here. So you can have search fields, you can have lists, checkboxes, radio buttons in the user interface. When you use an input field, such as a large text field, it's often because you have a large value set that you want to search across. And when you define that value set, it could be like a list of rare diseases you want to search. Maybe there are 150 and you don't want a drop-down list with 150, so you want this search field. And how you can define that set, you can either do it by a rule. So a query, you can say, show me anything in SNOMED that has these defining properties, as Ian was also showing. You can be very specific. Give me those concepts. But you can also create it manually. So we know that we have this set. We want to share this set, and we want to share it across the whole of France. So we make sure that these are the rare diseases that we use for capturing information about rare diseases. So there are options. You can be generic using the rules, and you can also go in and create subsets manually. So for a diagnosis field, you probably would just want to say, well, for this field, let's record anything that we can record anything that is a subtype of disease. In a procedure field, give us anything that is a subtype of procedure. And if we even have a surgical procedure user interface where it's surgical procedures, then we can also constrain it even further to say any subtype of surgical procedures. And if we are recording allergy information, let's not go with the clinical finding or diseases. Let's narrow it down to only those that are allergies, and so forth. So I think this is a key point for any implementer. That is, if you get this, you are well on your way to understanding how you work with SNOMED, is that you constrain it to the intended use. Because if you don't, you will end up with a mess. It doesn't help to have a good terminology or a good standard in any way if you don't use it properly. And this is what this example will show. If you do a search in the browser for malignant melanoma, you'll see many concepts returned. These are just 4. And this goes back to my point before with giving a clinician access to the whole browser. If a clinician is searching for malignant melanoma and see a long list of maybe 200 and something in the result list, how will they know which one they are looking for? They would need a very thorough understanding of the design of SNOMED CT to assess that, and it will take them a lot of time. So for example, would it be the first one that we will use for a new or current diagnosis? No, it wouldn't, because this concept is actually, and you can see that on the semantic tag, all concepts in SNOMED CT has what we call a fully specified name with that semantic tag, the brackets. And you can see it's a morphologic abnormality. And when you know SNOMED, that means it's a type of body structure. It's the morphologic abnormal structure, so it's not the real diagnosis. History of malignant melanoma is not the concept we're looking for either, because this represents a past history and not a current diagnosis, so something that happened in the past. And again, with the family history, we're again saying, well, it's someone, not the patient, it relates to someone in the family of the patient. And finally, we come down to malignant melanoma, a disorder, which would be an appropriate concept to use for a diagnosis. But then you probably also want a more precise concept saying what type of melanoma is it and what is the body site. And we also have those concepts in SNOMED. This I'll just show you this, because this comes from, it's an old one from 2014 by Dr. Jeremy Rogers from the UK, who did a study. I don't know if you know, but in the UK, SNOMED is mandated for use for clinical documentation, and this was like in the early days of their implementation, where they did an assessment of do we actually use SNOMED CT consistently if we give clinicians access to it, and the answers was clearly no, as you can see here, because here you can see what they search for. So a clinician would search for temperature. We can guess that, well, it's probably because the patient had a fever. They search for temperature. And in almost 1,100 times, they used temperature an attribute. And in SNOMED, that means that's a relationship, like ISAs or in finding sites. So it doesn't mean anything that has to do with a patient having a fever. And similarly, you can see, but it makes sense why they do make this search. It's completely natural. The same with the alcohol. If there's a patient having an alcohol intoxication, you would do like search for alcohol, but it's not the alcohol intoxication that you record, it's the substance. So doing this won't really get us anywhere when it comes to interoperability and consistency. And that's not the clinician's fault. That's the implementation's fault. And that's why it's so important. And I promise you, when we get further, you'll see that it's not so difficult, but it's a matter of having the appropriate approach to it, so that you are aware of how do we constrain it in the proper way. This is about when to use what controls. So if you have a large value set, you would probably use something like a search field. If you have a small value set, you can have a list. If you have very few options where you're very specific, every time we want to record whether it's this or this, you would use radio buttons. And if you have many options that you can select from and only a few, you would probably use checkboxes. The essence with all of this is that what you store and what you use for exchange and communication, analytics, is the same meaning and the same concept. So this is just to exemplify that family history can be recorded in different ways. You may have a user interface where you just have a title, like the one in the middle here with hypertension, asthma. The clinician knows the context, knows that this is about family history. We'll just click asthma. Down here, we will select family history of asthma. But in all cases, it's the same concept that we're recording. Our best practice principles recommendation is that you do text-based searches. Let the clinicians use the term. Make sure that the synonyms that you have created for all the concepts are sufficient to support the searching. And then having constraint searches so that you don't search across everything, but only the relevant concepts. And then if, for example, I was looking for myocardial infarction and I typed heart attack, maybe they typed heart attack, but what was shown was myocardial infarction. That will help the clinician to say, yes, this is the thing I'm looking for. So allow them to search with their terms, but use like the terms that are made consensus about in a region or a country or in a hospital, that these are the terms that we use, and make them display. So there's a difference. What do you allow them to search for and what do they see? And that's a way to be more consistent about what do we talk about in this forum. Now I'd like to jump to the demonstration. It's always exciting when someone tries to do a demo live, right? But I'm brave, and I've done it several times. So I'll just go, and you can actually also do this when you get back tonight and are super excited and want to look at this SNOMED.org/UI user interface. It is a demonstrator, so it's not a real production system, but it is a demonstrator. And what you see here is just a few user interface screens that you can see here, one with patient details, one with information about the encounter. There's also something about allergies and a summary. In this user interface, you'll see some fields with a blue S. That means that field has been bound to SNOMED. Because although we think SNOMED is a great terminology, it's not meant for everything. There are information that's outside the scope of SNOMED, such as the patient identifier, addresses, and all the metadata. That doesn't belong in an international standard. That's something we can't be standardizing at an international level, at least. And all these fields with an S indicating that they are bound to SNOMED also have the I, and that shows you the bindings of that field, okay? So in a real life system, you wouldn't see any of the blues. So, but what you can see here is that here we have an example where we have a limited value set. There are only 3. So if you went into the browser, you would see a range of concepts having to do with smoking behavior. But in this implementation, they have decided to only have 3 options. And these are the options. And there's also some intelligence put into this. So if I say I'm a lifetime non-smoker, you'll see that these fields over here are disabled. so I can't select them. And I'm a current smoker, and then you can actually define what other type of smoker. Okay, so let's go to the encounter. Being aware of time, I'm not going to do a search in all of them, but let us look at the diagnosis field here. And you'll see that this field has been bound to the clinical finding hierarchy. So let us just try to say appendicitis, to stick with Ian's example from before with appendectomy. I search for appendicitis here. I get, and if you look at all of these concepts, they are things that can be observed. It's a thing. It's not a procedure. It's not a body structure. It's a disorder or a clinical finding. Abscess of appendix, colic, burn, appendicitis. And you could also see as I typed, the results showed immediately. And that's because you can see here we use, right now it's an onto server, terminology server. I could also swap to another terminology server. This application uses the FHIR API to do a search. And because Snowstorm and onto server both support the FHIR API, it doesn't matter which one I use. It will give me the same. Let us try to type appendicitis here in the procedure field. What you see now is that I also get a list of results, but here it's appendicectomy, incision of appendix, emergency appendicectomy, interval, different types of appendectomies, but I don't get appendicitis. And that's because this field has been bound to procedure. And is essentially in this tool, how difficult is this? You are connected to a terminology server that understand this string here, descendants of procedure. So it's just a matter of creating like one query to say, this field is constrained to this set, and the technology will do the rest for you, right? So let me show you some. So when I select appendectomy here, I'm not giving the option to select a laterality. Because if you think about what Ian showed you before, the appendectomy is defined as a procedure. It has a method of excision. It has a procedure site direct of the appendix structure. And we don't have a left and a right appendix structure. Even the appendix structure can be lateralized. We can't say there's a left part and a right part. So in SNOMED, all body structures where you can say, well, we have a left lung and a right lung, a left knee, a right knee, that they are lateralizable. So we put all of the concepts that are lateralizable in a set so that machines can utilize that. So let's say that we were doing like a kidney excision. You would now see that I'm able to select the laterality, because it does make sense to have that enabled now, because we want to say whether it's a left or right kidney that we are excising. That matters. And there are some concepts in SNOMED CT that already have a laterality. CT of left kidney, for example. Often you would do both at the same time, but there is one for CT of left. And now you can see it pre-populates the laterality. So it takes the defining properties of that concept and populates it there. So now I can start to say I did a CT of the left kidney with the laterality of right. The system allows. So it helps me not to make mistakes. So that's a simple example of how some intelligence can be built into systems very easily with the derivatives and the modeling that comes with SNOMED. So you're welcome to come up and try it on your own and ask questions if you have any. I'll move on to query and analytics. Yeah. So there is yeah. Thank you for asking that. So the question was to you out online whether or not we provide you with the rules that we've built. So every time we build a tool in SNOMED International, we do it open source. So We have a GitHub repository I'll show you in the afternoon, where all the source code for the tools that we are showing you today, and the documentation and the bindings are there, and that's actually what you need for that. So yes. So moving on to query and analysis. So think about that structure of an electronic health record that I was showing you before, where you have the patient data store and the terminology server. If you want to look up a diagnosis of a patient in the record, the data structure of your record will inform you about where to find that information. You don't need a terminology for that. It's just looking up what data is stored in the diagnosis field, and then you will find it. So the answer to this question, you don't need a terminology for that. So you can just use the information structure. But you need a query to know where in the health record are you looking. Of course, you need to understand how you store your data to find out where to look. Another example, if we want to ask, does this patient have a kind of infectious disease? Or does this patient have any procedures been performed on the cardiovascular system? If you start to ask that type of question, then it becomes more tricky. And then you need a terminology. Because yes, you need to know where in the health record to look. So it's still the diagnosis field. If it's a kind of infectious disease, if it's procedure, it wouldn't be the diagnosis field. I would look in the procedure field. So I can come part of the way. But to know whether it's a kind of infectious disease or it's related to the cardiovascular structure, that is where either you need to manually go through the list to identify those that are infectious diseases, or you need something to help you identify it easily. And that would be where the terminology comes in. It's the same for the procedure example. So for example, if we want to find all the procedures, we'll get the list of procedures, and then we would look at those concepts and match them against all the concepts in SNOMED that are subtypes of cardiovascular procedures. And then we would make a comparison, and then we would get the result. So that process here, get concepts that are subtypes of cardiovascular procedure to get all cardiovascular procedure concepts to compare with. That process is why you need a terminology server or some services that allows you to use the hierarchies in SNOMED to find them. And we have a language that is called the SNOMED CT expression constraint language, so a query language. If you notice before in the user interface, there was this like small single less than sign before clinical finding and before procedure. So that small, the small doc thing. And that's part of the expression constraint language. I'm going to show you just in a moment, but that's a query language that allows us to query over SNOMED CT. And it supports all of what Ian also showed before. It allows us to do analytics. And I'll just skip through those. I've seen them. So now let me show you the principle. Before I show you a practice example of this, let me talk about the two ways that you can think of analytics with SNOMED, either using the polyhierarchy or using the defining properties. So all of it is about using the definition of a concept, but using the polyhierarchy or the hierarchical structure could be done in this way. So here you see 4 concepts: colitis, appendicitis, pneumonia, and bronchitis. They are all part of the disease hierarchy in SNOMED. And this is a very simplified view. In SNOMED, there would be many other concepts in between disease and these concepts. And if we want to look up the inflammatory disorders, it's a matter of finding the concept that we want to look for, and then getting all the subtypes of that. So we would use the ISA relationships to go down, and then we can actually find whether or not these are inflammatory disorders or not. And that's useful for data analytics. So if you have patients if you want to count patients and identify patients, maybe for clinical trials or anything, and you have patients that have been diagnosed with these disorders, and your server would then have a service to answer this question, people with a respiratory disease. Okay, so you need to know that you want to find things that's your task as the data analyst here. I need to know what I'm looking for. I'm looking for things that are types of respiratory disease. And then it's up to the system to then identify, okay, these are the concepts that are types of respiratory diseases, match that against the patient data, and then you'll get the results. And exclude those that should be excluded and include those that should be included. It can also help to answer simple questions for a specific patient. Does this patient have a lung disorder? We'll know that we want to know about lung disorder, and we can compare to the diagnosis of the patient, and then we can answer no, it's not a lung disorder. And you would say, well, the clinician knows all of this. Yes, but this is also a very simplified example. There may be other things when it comes to research questions where the questions are not that obvious. So that is about using the polyhierarchy and saying, give me anything that is a subtype of something. Then we can also use the defining properties. So here we have 8 concepts. All of these concepts are defined with a finding site property. Some are to the colon, others to the appendix structure, lung structure, knee structure. The top one here, they all have an inflammatory morphology, so a defining property of associated morphology. And those in the bottom, this one have an associated morphology of dysplasia. These have fibrosis, and this has abscess. So that's how these concepts are defined. And the way that we can use that for data analytics is to say, well, give me any people with a disorder that is located in the colon structure. Then the system would need to run a query to say, well, give me all the types of disorders that have a finding site of the colon structure. So using the defining properties instead of just the subhierarchies. So here we say we need to then know the attributes that we're looking for at the finding site with a value of colon structure or any type of colon structure. And a similar example with fibrosis morphology. We would be able to find both those with fibrosis of appendix and those with fibrosis of lung just by saying, give me any diagnoses that have an associated morphology of any type of fibrosis. So as you can see here, when doing data analytics with SNOMED, it's about knowing what you want to know. And that's an important first step. What are the questions? And it actually also talks to why you need to work with a clinical terminology, a standardized clinical terminology, because you don't know what questions you want to ask tomorrow, right? So when we work with statistical classifications, you know what we can count. We can count the groups of pneumonia. We can count the groups of infectious. It depends on the chapters and the categories. That's what you can count. SNOMED is designed to be like exhaustive in the manner that we don't know what to count, and we try to just define all the things that we can say about this clinical idea to an extent that it will help us when we certainly get a question. We can be very specific so that in asking those questions and get the answers. So the questions, obviously, that's for the data analysts and the clinicians. Then there are some middle layer, some informaticians who then need to know if this is the question, then we need to find these concepts in SNOMED. So be able to formulate what concepts in SNOMED are we then looking for. And then transform that into the correct expression constraint or the right rule that can be understood by a terminology server. So this is just to say that you come from something that is very clinical, right? But then you need some software and you need some people to have. That's also why not everyone needs to know everything about SNOMED. Clinicians will need to know something about SNOMED. Then there is a smaller group involved with the implementation that needs to know a lot about SNOMED. And then there are those building the systems that need to know a lot about terminology services and making the queries. So it's really about how do you engage the stakeholders at a right level to do SNOMED CT implementations. So these are the examples of the expression constraint language. The syntax it's growing, and it started out with a very concise language, and now it has expanded to have many features to accommodate many of the user requests that we get from those implementing and using expression constraints. Now I want to show you an example of data analytics. I'm just looking at the time. How long time do I have before the break? Is it on? What? 12:15, is it? That's good. Good. So Ian was also talking about this, that one of the common data analytics scenarios is that you want to assess a treatment, or you may want to give advice to a patient. And that's the scenario I've decided to show for you today. We have different analytic scenarios, but because of time, I'm just showing this one. So this is an example where patients or people have been identified with a mutation of the BRCA1 gene. And this gene is helping people to create a protein in the body that acts as a tumor suppressor. So we have this gene, and which means that it will help us not to get cancer, essentially. So if you have a mutation of this gene, this BRCA1 gene, you are in an increased risk of also getting cancer. Especially with these females here are in an increased risk of getting breast cancer. And you can imagine being a patient coming in and say, we've found that you have a mutation of this gene. There may be some family history, something that does it so that this test has been performed. And now this patient is contemplating about the options, because there are options. You can start to take drug to prevent breast cancer. So there are some preventative medications. But that comes, if you do that, then you have to face the side effects of that medication. You can get hot flashes, you can get bone pains. There's significant side effects to having these drug preventive medications. And then it's natural for a patient then to think, or a person, because this person may feel completely fresh, right, well, and she doesn't have cancer. So should I start to take some preventative medication that will make me feel very unwell to reduce the risk of me getting cancer? That's really that's difficult. So of course a patient would want to know, will this preventative medication, will it really help me? Will it really decrease my risk of getting cancer? That's natural. So the clinician can't say, you won't get it, or you will, but they can help inform. And how can they do that? By knowing the statistics and knowing about so some evidence. It's evidence that this amount of people, that if you start to take this, you will have this reduced risk of getting cancer. So that's the scenario. And this is how SNOMED can help you. So to make that type of analysis. And those of you who have been involved with research, there's a lot more to it than just identifying correlation. It needs to go into a real research project and with the proper evidence level to say that we have evidence for this. So please bear in mind that this is just showing the principles, like to do the real medical study. So if you have a population and you then want to say, well, give me all the patients who have a BRCA1 gene mutation. That result of that test that someone has, that there is a positive finding of a gene mutation, that can be coded with SNOMED CT. So we can use SNOMED to say, give me all of those patients that have a gene mutation positive result. We can also use SNOMED then to say, well, who in this population are then taking cancer preventative medicine and who don't? So that we can divide this group of people in the risk groups into two, those who do take the cancer preventative medicine and those who don't. And then we can look at who within this group then get breast cancer after having been diagnosed or having started to take this cancer preventative medicine. So there's also a time aspect involved, and that goes beyond SNOMED, and that's where you need to have a concise model and an agreed model. But that's the principles. So now we know what questions we want to ask. We want to know who have BRCA1 gene mutation, who are taking cancer preventative medicine, who gets breast cancer. Those are the three questions. So what do we need then? These are the SNOMED concepts we need. And these are the queries we need to run. So let me now jump to the tool. Now I need UMail, because I tried the tool just when Ian was doing the introduction, and I found that it didn't work on my computer. Fortunately, it works on Mael's computer. Okay, so again, this tool is a demonstrator. It's called Snowlytical, and it's a tool. It's not open for anyone. The code is, so you can actually implement it and play around with it yourself if you're a coder. And if you want us to do a more thorough demonstration, we are happy to do that, set up a session. And otherwise, we also have some recordings of it. But I'm just going to, there are three scenarios that we show in this tool. And one of them is what I've just been talking about here, the treatment comparison. The data set that we use here is a synthetic data set. And it's, I think it's almost 1.3 million patients that we have in this data set. And we have compared some of the scenarios with some Nebraska data, I think. And it is actually quite reflective of how their real data looks. It's just to say what we're looking at here are example data. So now we are looking at this data set with almost 1.3 million patients, and we want to identify those patients who have a BRCA1 gene mutation detected, right? So now I do a search in SNOMED, and I said that it's a clinical finding, so I make sure that it's the finding. So now my cohort size is down to almost 1,200 patients. We could also filter on the females. I think they are all female. And now we want to look for treatment options. Cancer preventative medications. We looked up on the NHS website how they recommend that you preventatively treat patients. It's not called treat when you prevent, right? How you prevent people. And there are three drug products. There are products containing the substance called tamoxifen, and there's a product called anastrozole and raloxifene. Those are the three main active ingredients in the products that are used for cancer or for this breast cancer prevention medication. So we have created this subset, and we've done this by saying, well, give me all the products in SNOMED that contains tamoxifen, give me all the products that contains anastrozole, and give me all the products that contains raloxifene. So regardless of if it's in tablets or if it's in the infusion mechanism and everything, it doesn't matter. But these are, because there can be variations. So we want all the drugs. So it will make me very easy to get this high number of concepts probably just by this query. So I've created a subset. So let me go back to treatments here. Oh, now it's typical. I shouldn't have gone that. So we'll do it again. Now you know there is a subset. So we'll add those that have pharmaceutical product of the, I'll just type breast. No, I won't. I will try again. One thing is to do a live demo, and then another thing is to do it with one hand. So now I just type breast here, and you can see I get the subset. Okay, I could also, just to show you, if I had typed in, I think I need to remove it and then add it again. If I had typed tamoxifen, just tamoxifen, you can see I get tamoxifen containing products. So if I was only interested in one of these, I could just do it by just saying tamoxifen containing product. I wouldn't need to create that subset. So if I select this here, what you will see here when I hover over is that the underlying expression constraint is the descendants or self of tamoxifen containing product. So if I were the information analyst here, I wouldn't even need to care about the expression constraint language or those rules. I just wanted to care about the thing I was looking for. So let me again just try to show you the one with the subset. Okay, so now I'll just take those who take Previn. And then I want to include those who don't take it. And I want to then say, well, I want to figure out who gets a malignant neoplasm of breasts. And as you see, I'm typing in breast cancer. Remember what I said before about what you search for and what you show. So here I search for breast cancer, but I get malignant tumor of breast, and that's what I want. So now I will run report. You could also configure a system to show the synonym breast cancer if that was what you preferred. So that's the design decision. So now we had 1,200 in the cohort of people who have been, or females who have been identified with this gene mutation. And we see that those who take prevention, there's a 30% risk of getting breast cancer compared to 73% risk for those who didn't. And I think this is also about user interface design and what I said earlier about what is will SNOMED be accepted? Will a clinical terminology be accepted? Well, it does depend on the type of tools you give them, whether it's for data analytics, for data entry. If it fits well with their work processes, if the things they see is meaningful, then I think there's a great risk or chance for succeeding with this. But it does require efforts on the implementation side. So now we'll go back to my machine. Yeah. So that was where we come from before the demo, that you have the questions, you need to find out what content in SNOMED, then you need to have the expression constraints or the rule. And I'll use this. Think, unless it sleeps. So working with SNOMED for data analytics is very much about set theory, right? You need to, what is the set of concepts I need to know? What do I want to exclude? What do I want to include? And this is just a principle of what is it that goes on. We have some data that is recorded with a diagnosis. Then you have a terminology, and you want to select all the patients from your record that have some kind of malignant tumor of breast. So your terminology server will find all the concepts in SNOMED CT that represent some kinds of subtypes of malignant tumor of breast, and then you have the basis for comparing your patient data with the expansion of your result of your query. And so that's just the basic principle. And there's nothing more to it than that type of comparison. You just need to have the right sets that you compare. So now we are to the place in the presentation that's on interoperability. When you start to work in health IT, there are many benefits, many visions about where we want to go. And that's good. That's motivating. We have an idea that we want an increased efficiency, accuracy, high quality, all the things that we have spoken about all morning. But the fact is that if your approach to implementing any digital system in healthcare. If you just take the papers that have been working so well for the last 50 years and plug them into the computer, there's a very there you'll definitely get happy clinicians for a while because it will look the same. I can recognize it. It looks very much like the paper. Now it's digital. Okay, that's part of the way. That's that acceptability. However, I can guarantee that just taking what you have on the paper and put it on a user interface, that won't help you achieving all the visions and all the benefits. It will never help you to get the interoperability. So you need to take the step and talk about standardization, which is also why we are here today, which is fantastic. Because why do we get light out of these lamps up here? It's because we are using standards for electricity. Why is it so easy for me to fly from Denmark to France? It's because we use standards for our passports, for everything. I can pay, we use it everywhere. And the fact that we are not using it more in healthcare in 2023 is a bit worrying, I would say, but that's why it's good that we are here. There are many layers of standardization. And two of them, which I think is important for us to talk about today, as it's a SNOMED session, is the terminology and the information models. Because you can't talk about SNOMED without also talking about information models. The terminology, I won't read this out loud because you've just heard the introduction from Ian, and that's what a terminology is. It's about the terms we use within a field. The information models, on the other hand, is how do we manage all the things that we document in our records? How do we organize it? How do we structure it? And a term such as an information model, I bet if we are 30 people here, we have 30 different perception about what an information model is. And we are okay. It's okay that we have that because an information model is not just one thing. Information model is a very broad term that is used to talk about many different things. So you looked at the user interface I showed you before. That's one kind of model. We say that we want a field for smoking status. We say that there is a diagnosis field. We say that we have these three user interfaces or four. That's a user interface model. So that's also a kind of information model. A storage model is more when we talk about an ER diagram. We say, well, in our database or in our data storage, this is how we want to store the information. We separate these values, we normalize it in this way. So that's also an information model, but that has to do with the database design. You have communication models, messaging. So that's where we often talk about a thing like FHIR, right? So FHIR is something you would use to communicate. You can also use it to store. But certainly the beginning of FHIR was about making fast interoperability and communication. And that's also a type of information model. So this image here is just to say there are many different types of model. An information model can be something you have written on a paper to say, well, in this region, we agree that these are the sets we use for this type of information, or at a national level, these are the rare diseases we want to capture in this register. An information model is many things. That was the point. So let us now look at an example of an information model, which is a FHIR. In FHIR, you structure the information and all the information you would want to exchange across borders about patients, conditions, treatments, and so forth. And they create these resources. And a resource here this is an example of the patient resource. And they state what are the different things that we can record about a patient. So I agreed that a patient have an identifier, a name, a gender, an address, a marital status, maybe there's a photo, and there's a general practitioner. So in HL7, they have in the forum defined these are the things that you would want to capture about a patient if you want to share information about a patient. And there's also cardinality on, so saying you may or may not have this information included, or you may or may not have so many instances of this. This is the procedure resource. You can see it gets a bit more complex when it comes to procedure, but in essence, it's the same. So a procedure has a code. It relates to some person. Either it's the subject of the record, it may be a family member, it's something. It's a procedure that has been performed. There's some practitioner. There can be, I think it's a verification. So there are many different types of information. And the last one to show here is the condition resource. So how any conditions that a patient have, you may again say, well, the condition has this code, it has this severity, it has a body site. And again, the cardinality will tell us whether or not it has to have it or it's optional. So this is different from a terminology because this says in a context of a condition, a patient, a procedure, a problem, these are the types of information that we need to be able to communicate to understand across borders. And then in these models, here we see it's the problem condition. There was a code, and you can see there are different types. So these are all codable concepts. And that will tell us that the value that you'll find here in that part of the model, that is a codable concept. So that comes from some coding system, okay? And the code can come from a coding system, the severity, the body site. And here you can see they recommend that you use SNOMED body structures. There's the examples of the codes that you can use for the code, but that's where we would say, well, if it's a condition, it's a disease in SNOMED or clinical finding. The severity, we also have severities in the qualifier value hierarchy. So the model will say, well, these are the types of information that we need to record, and the terminology will be the actual semantics and the actual data values. And here is an example. What is it I'm trying to show here? So under the code, right, I said verification status, code, the subject. So here under the code, you will see the system, which is SNOMED, the code, the identifier, and then the display term. The term is the fully specified name here that is exchanged, but the text part of this code is the preferred term that was displayed on the user interface. So the text will tell you what the clinician saw. So in the information model, we have these building blocks, and in those building blocks, SNOMED CT belongs in some places. And they can't go without each other. There is a dependency between the two. So standardization is not just about taking the step to start to use a standardized terminology. It's also about agreeing on the models. They go hand in hand, because if some organization use one model and another use another model, how do we know where we are trying to say the same thing or represent the same meaning? And this linkage between the terminology and information model is also what we call terminology binding. So when you bind a certain part of your data model, I need to go back, where you say, well, in the body side, well, if this is an information model for eye problems, maybe it's not enough that the code has been bound to all clinical findings. Maybe we only want those disorders that are eye disorders. So in the process of developing some model for a specific domain, it may be that you want to specialize them. So you may have on a national level some generalized models to say, well, for this field we use SNOMED and this hierarchy, but within then a certain specialized domain, we may constrain it even further. And that will help standardization, because you know then what specific concepts you want to be able to exchange within a certain field. So why is it important? It is to make things easier. It is so that we can just push the button and then it works, to make it more fast, to get higher quality, and to allow us to interoperate. But there's more to it, because it's not that easy. It sounds easy. You have an information model, you have a terminology, they need to work together. But the fact is that the devil is always in the detail, and the detail is here, and the devil lies here in the middle when it comes to context. So as you will see when you work with information models and terminology, there are overlaps. So in SNOMED, you can actually represent a lot of contextual information in the hierarchy we have called situations. And in information models, they may have different ways of structuring it. So it's a matter of when you go towards achieving semantic interoperability, it's about having those discussions. So where there are overlap, do we use a model to represent it, or do we rely on the terminology? And it is a matter of having those discussions and settle on a thing, and then be consistent in that decision. Let me give you an example. If you have a concept, so we just looked at the breast cancer concepts from SNOMED, so the malignant neoplasm of breast. And if you just take that diagnosis concept in SNOMED and record it in a search field, maybe that search field has a title that the form is a family history form. So we know that breast cancer is now documented in the context of family history, because that's our model. Over here, we are using the same concept, but we record it in a form for medical history. So something about the past history of the patient. And over here, we record breast cancer to say that this is something that the patient has now. So we use the same SNOMED concept, but now we use it in 3 different ways. And that's not a problem for us here, because we can read and understand. And this comes down to the brain, Ian, where half of the brain is a machine and half of the brain is human. We need the machines to be able to interpret this correctly as well. So imagine that here's another example where you have 3 systems. So here we record breast cancer, the concept breast cancer, but we do it in a model for family history. Over here, we have a very loose model. You can put anything in. So we just use the SNOMED concept for family history of breast cancer. So these 2 systems, they record the same meaning, but here the context will tell us that it's family history, and the term will tell us that it's breast cancer. Over here, the terminology tells us everything. And over here, we have a mix, right? We have a system with a very loose model, but we have 2 fields, one for the code, the breast cancer, and another one for the subject, person in the family. So all of these systems are okay. They represent the meaning. If you want to record a family history, they all allow us to do it. But that is very difficult now, because now we want to exchange between these hospitals or these systems. And if we just use the terminology, if we just, we communicate using SNOMED, they will all forward breast cancer to the other one. But if we don't have the context, if we don't remember the model here, they will understand this probably as the patient has breast cancer, and not that it was something that was in the family history. So this is just to exemplify why it's so important when it comes to interoperability to have a shared model and apply the terminology appropriately in that model. Here's another example. It's just to add a bit more complexity. So here, 3 hospitals, it's suspected breast cancer. So now it's not only that it's whether or not it's in the family history, it's whether or not it's suspected or the verified. So in the fire condition resource, we have a verification status, we have a code, and a body site. So between those 3 hospitals that record this information, they agreed that they want to be able to share the information and understand it. And they agree that they want to use fire for this. And they want to use not all of this, because that would be, they have just agreed that they want these 3 elements. So they use fire with a code, body side, and a verification status. That is how their message model look. So how can they do that? This table here shows you that hospital A, they are in a good position, right? They were clever because they just have a code, they have a body side, verification. So their user interface model is very much aligned with their communication model. Can you see that? So they can put cancer, breast, suspected. Boom, they are done. Hospital B, they are part of the way. They have a problem and a body side. So they put in suspected cancer, breast, and then they don't have the verification status. We can see that that's part of this concept. Over here, they only have one field, suspected breast cancer, that's the code. We don't have the value for the body side or the verification status. So this is where we have using SNOMED will help us to actually derive the information that is required by our information model or our communication model. Because from these informations, the machine can actually derive these values. And let me just show you how. This is hospital B, right? This one. How do we get this suspected here? We do that because suspected cancer, the code they have used, suspected malignancy, that sits in the situation hierarchy in SNOMED and is defined as you see here. It is a type of suspected disease. It has an associated finding, malignant neoplastic disease. It has a finding context of suspected, and there we have it. It has a subject relationship context of the subject of the record and a temporal context, current or specified. So we get that information about the verification status from the definition of the situation that was applied. It goes the same for hospital C. And then the value of the body side is to be found in suspected breast cancer here. If we look at suspected breast cancer, we get the verification status directly from how it was defined, but then you can see that it has an associated finding of malignant neoplasm of breast. So this concept in SNOMED CT, suspected breast cancer, is defined with having a finding of malignant neoplasm of breast. And if we look at that concept here, you can see that malignant neoplasm of breast is defined with a finding site of breast structure. So by traversing the defining properties, we find what we're looking for. We find the information we need to be able to communicate with all the data that we want in our message. And then we have had a bit of discussion about, but what do you do in the code field? So right now I've shown that we say cancer, suspected breast cancer. That could also be normalized, right? You could actually say, well, we don't want to allow both clinical findings and situations. We may want to forward the code that was recorded, but we also want to derive the core clinical finding, cancer, and you can derive that from both of them as well. Yeah, I know. I always get that feeling of, okay, when we start to talk about this, it becomes a bit heavy because it is difficult and it is in the detail. But I really also hope that it can inspire you to say, well, it is possible if we have the right tool, if we have the engines there, then it doesn't have to be difficult. And the tooling, if you get people who can build the things, then it's a matter of you specifying the requirements for what you want to be able to do, because it is doable. Yeah, this is just an example of how. I think with time, I have something about terminology binding, but I can't do it in 4 minutes. It'd have to be another time.